Hello everyone, here is a question based on chemical bonding. The type of hybridization and the number of lone pairs of electrons of xenon in xenon oxytetrafluoride respectively are which one? Let us first count the total number of valence electrons in xenon oxytetrafluoride. We have 8 valence electrons in xenon because we consider 5s2 and 5p6 as the valence shell, plus 6 for oxygen, plus 4 times 7. We are ignoring the 1s2 core here, both for fluorine as well as oxygen. So therefore in total 14 plus 28, that is 42 valence electrons we have. So using 42 valence electrons, let's write down the Lewis structure. We have xenon at the center. Then let's make one bond pair between xenon and fluorine. Let's also make one bond pair between xenon and oxygen. Now we have utilized 10 electrons. So let's put 3 lone pairs each around each fluorine atom as well as one oxygen atom. So in that case 6 times 5, 30. So 30 plus 10, 40 electrons we have utilized. We still have one more lone pair that we can put on top of xenon. But this is not the best Lewis structure for xenon oxytetrafluoride, because if you determine the formal charge here for xenon, then it would be number of valence electrons, that is 8, minus number of lone pairs of electrons, that is 2, minus number of bond pairs divided by 2. So that would be 10 by 2. So 6 minus 5. We are getting plus 1 as the formal charge for xenon. And likewise, if we calculate the formal charge for oxygen, we would get minus 1, because for oxygen it would be 6 minus, we have 3 lone pairs. So therefore once again 6 minus, we have 1 bond pair, therefore 2 by 2. So therefore this will be equal to minus 1. So that's what I have put it here. So therefore we have to bring one lone pair to the bond pair. If we do that, then we can get the correct Lewis structure for xenon oxytetrafluoride, and that would be Xe and then double bond oxygen and then 4 xenon fluorine bonds plus 1 lone pair on top of xenon. This is the best Lewis structure for xenon oxytetrafluoride. Now the formal charge will be 0 for each atom. So this means, what is the steric number? Steric number is number of lone pairs of electrons plus number of sigma bonds. So therefore 1 plus 5. Steric number is 6. If the steric number is 6, then the hybridization has to be sp3d2. Xenon belongs to period 5, isn't it? So therefore it belongs to expanded octet configuration. It has access to the empty 5d orbitals because it belongs to period 5. So therefore hybridization is sp3d2. We have one lone pair. This means option 1 is correct. By the way, the electronic geometry for xenon oxytetrafluoride would be octahedral, but that is only electronic geometry. Electronic geometry is octahedral because the steric number is 6. But what is the actual molecular geometry? Actual molecular geometry is square pyramidal. Actual molecular geometry is square pyramidal.